Question 18. A swimming pool designer is modelling a diver by dropping a wood cylinder. Here's mass divided by volume. -3 kilograms. Volume is going to be volume of a cylinder, which is going to be pi r squared times the height. So pi r squared, pi times the diameter, well, the radius is going to be half the diameter, 0.5 times 10 to the minus 2. So 0.5 times 10 to the minus 2 squared times the height, or the length, so 7 times 10 to the minus 2. The volume, if you work it out, comes to 5.5 times 10 to the minus 6. So mass over volume, 5 times 10 to the minus 3 divided by 5 times 10. The density that you're looking for is 910 kilograms per meter cubed. Done. Part 2. Suggest why wood is an appropriate material. Notice 2 marks. So 1, the density of wood is similar to a human. 1 mark. And secondly, why is that important? Well, the density of wood is less than the density of water. Okay, so it floats. If it didn't float, then as you dropped it, it would continue sinking and never bounce back up. So 2 marks. Part B. The cylinder is released from rest. The base is at a height 0.3. Calculate the speed of the cylinder. Well, this is just going to be a simple v squared equals u squared plus 2as. And if you stick the numbers in, the u is 0. V turns out to be just 2as, so 2 times 9.81 times 0.3 squared, and V, if you work that out, therefore is 2.4 meters per second. Done. Part C shows the cylinder fully submerged. Add the 3 forces and label the arrows. So what forces we've got? The weight, if you want to put mg, either is fine. Okay. We have drag. What direction does drag act? Okay, drag. If you put friction, that will be acceptable. It's in the opposite direction from the motion. And of course, there is the up thrust. So as long as you've got it pointing upwards, doesn't matter where you put the arrows, as long as drag and up thrust upwards, weight, mg, is downwards. Again, 1 mark for each. C2, describe and explain. Okay, the resultant force you know that it slows down, isn't it? It slows down as it falls, stops, and then moves back up. So if it's decelerating, the resultant force must be decreasing. Okay. Thrust is going to be the difference due to the difference in pressure between the top and the bottom. Well, the height doesn't change, therefore the up thrust is constant. I think a lot of people miss that out in the exam. Okay, you could say, therefore, also If up thrust is constant, if it's decelerating, therefore the drag reduces. That's for your second mark. And finally, at the lowest point, what direction is the force? The resultant force is upwards. It's going to start to move up after it's stopped moving. 3 marks. Finally, part D. The graph shows the depth reached for different initial heights. The designer suggests you need to double the height of the pool, or double the height of the double pool height is right for double the diving height. Is that true? Okay. It says use figure 18.3 to explain whether you agree with this suggestion. Again, 2 marks. So obviously it's not the case. This is not a straight line here. If it was a straight line, if it was some sort of proportional relationship, okay, it might be true. So firstly, the graph shows, that is figure 18.3, it's not proportional. And really you should say what is not proportional. Okay, I guess the depth of the pool is not proportional to the height of the diver, so using the 2 axes here, depth and height. And secondly, you need to show that from the graph. So if you show, for example, that maybe from 0.1 to 0.1 the increase is a large amount, so from 0 to 0.1 meters in height, then the depth goes from about 0.09 to 0.14. That's an increase of about 0.05 meters. If you got the height from maybe this point here, 0.5 to 0.6, much less, so 0.5 to 0.6. Depth only increases from about 2.25 to 2.26. That's going up by about 0.01 meters. So as long as you've done some explanation relating to the graph, you get the second mark.